Myself, A. Rajalakshmi, Assistant Professor in Mathematics, Knowledge Institute of Technology. Now I take a topic is sequential series. Sequential series is learn what a convergence sequence, what is a convergence sequence, learn how to find the sum of the infinite in geometric sequence. Here the geometric, what does mean by geometric sequence series is, we know from last lesson that the sum of the term in the geometric sequence can be given by Sn is equal to u1 into r power n minus 1 divided by r minus 1. Some example, find the sum of the first 10 terms of 3 plus 15 plus 75 plus 375 plus and so on. Here we have substituting un is equal to 3 and r is equal to distance is 5, n is equal to number of terms 10, Sn is equal to 3 into, we have substituting the formula, get the answer. Series is the nth term of the test. This test can applicable to the any series. Limit of an, sequence of an is the sequence of the terms. We have using the sequence. Remark is, if the limit is 0, the test is fail. This means you must try to the different test. Sometimes the limit is not easy to evaluate. In this case, try to the another test that you think might be more productive first. You have to find what is the series and sequence is convergent or divergent. If in case the test is equal to 0 means the test is failed, you have substituting the another test. We have applicable to the series using the 5 tests. The first one is the integral test. This test can be applied only to positive term of the series. Integral test, you must find a continuous function f of x such that first you find an value which is equal to f of n. You have substituting n is equal to x, verifying that f of x is a decreasing function. That means f of x, f dash of, we have differentiating f of x, f dash of x value which is less than 0. Then integrating the term, the value is finite, the integral test is convergent. Equal to infinity, the integral test is divergent. This is both the convergent and divergent test. If f of x is an increasing function, go to the nth term of the test. This test required that the function can be integrated. It will not work to the series whose the term factorials in them. Next one is a comparison test. This test can be applicable only to the positive term of the series. You must decide if you think the series convergence or divergence. If you think it convergence, you must find a largest term series that you know convergence. If you think which is at divergence, you must find a smaller positive terms which is less than or equal to 1 means that is divergence. Conclusion, if you find the largest term of the convergence series, then your series is convergent. The function p value which is greater than 1, the value is, the series is convergent. In case the value is which is less than or equal to 1, the series is divergent. A remark as with the nth term test, when the test fail, it means you must try to another test. The test works well with the series that look at most like a geometric series or P series. Next test is limit comparison test. This test can be applicable only to the positive term of the series. You must decide if you think the series is convergence or divergence. If you think it convergence, you must find the positive term convergent series that has the same n behavior as yours. If you limit value which is equal to 1 means the test is fail, comparison test is fail. Next you have proceeding the limit comparison test. How satisfies the limit comparison test? 0 which is less than limit n tends to infinity bn divided by an value which is less than higher than the terms. Then the both convergence or both series is divergence, which is equal to 0 or increases without bound or does not exist, then the test is fail. The next one is remark, when the test fails, you must either find the another comparison series or must be tried to the another test. Ratio test. This test can be applicable only to the positive term series. Ratio test, you find un plus 1 and un value. The ratio un plus 1 divided by un value which is less than 1, the test is convergent, which is greater than 1, the test is divergent, equal to 1 means the test is fail. The nth root test, this test can be applicable only to the positive term series. Nth root of an value, next you have proceeding limit, taking the limit n tends to infinity, nth root of an value, the sequence of the term is nth root test. Conclusion, if the limit value which is less than 1, then the series is convergent. The limit value which is greater than 1, the series is divergent. Equal to 1 means the test is fail. This is both the convergent and divergent test. This test can be used to prove the absolutely convergent. This test will not work on the series whose terms are rational functions of n. The test work well the series whose the terms of power of n in this nth term test. Absolutely convergent, this test is used to the series with every signed term. If the sum of Pn convergence, then the original series is convergent, absolutely convergent. If the sum of Pn is convergent, then the original series is convergent conditionally or it divergence. Here using the absolutely convergent test, some remark is there. If the sum of Pn divergence, then you usually use two alternative series test to determine the original series is convergent. Alternative series, you must use this test only. Alternative series, this test can be applied only to the series of alternative terms. Alternative series proceeding un is decreasing sequence. Evaluate limit n tends to infinity un value which is equal to 0. If the limit is 0, the test is convergent. Thank you.